Cool.
Hi, every Hi
Hello,
everybody.
everyone. Thanks for staying with us or joining us. And we already have our next speaker here after a bit of technical issues. But we're very happy to have Henrik Feld joining us. So Henrik, I think you're our last European on the program, right? Where are you located right now?
So I'm in Stockholm, and it's quite late here. It's black dark outside.
I thought it's always dark in Stockholm.
Well, from 3 o'clock in the afternoon, but
From 3 o'clock in the afternoon. Oh, okay, well, maybe I'll go there in the summer instead.
yeah, that's a good bet.
That's a good plan. No, I was actually in summer in Stockholm. It was really nice. Cool. So you're one of the people who's going to talk about microservices. So
That's right.
what can we expect from your talk?
So during the talk, I'll go through a few of the thoughts I have on microservices. It won't be a purely technical discussion, because when it comes to microservices, they're as organizational as they're technical. But of course, this is fsharpConf, so there'll be a bit of F Sharp, a bit of Docker. So I'm keeping my promises.
Sounds really cool. So I'm really happy to have Docker here, because that's just another sign of the cross-platform ecosystem working really well. So I think we are good to go. I'm going to switch over to your screen so that we can see your slides. That's it. And over to you. We're ready.
Thank you. So I'm just going to get started here then. And this is the talk, Microservices, Docker, Loggery with F Sharp. Oh my. So tonight is the night, and it's night in Sweden, so hence the night of the metered microservice. In this presentation, I'll go through a bit of what I think about microservices and thoughts that you also can have on them. And then a bit about F Sharp as a language for distributed computation. But I'll try and weave that into how you build and deploy microservices, rather than going for the language-specific point of view. Then I have a bit of a demo with InfluxDB metrics from Loggery and Docker. And also, I misquoted a law here, maybe a bit. But who am I, first of all? Well, I'm very pro indeed. I'm distributed systems aficionado, but I have about 12 years of experience programming, started quite young, definitely 8.2x. And I sometimes call myself a philosopher of software, which may or may not be true, but it's fun to think about software, so that's why I like the epithet. So what about me and my work? Well, I'm the CEO and founder of Kvitt2.com, content partner at F Sharp TV. I'm working with Ademar on Sav.io. There is a build system called Albacore version 2, which I've created from scratch. That was based on version 1. But version 2 makes it quite easy to build cross-platform services using Ruby, actually. I built a library called Loggery, which I'll show today. And I also dabble a bit with Docker. So without further ado, let's have a look about microservices. So the first thing about microservices, in my opinion, is that it's about scaling organizational structures. As the number of people in the organization grows, it becomes exponentially hard to communicate with everybody. And microservices, they let you specify some invariants that you then hide behind an API, which you can also enforce with an SLA. And that makes it easy to isolate pieces of code behind an organizational part. So if you have multiple distributed teams, for example, you can let microservices do their work and have each team do its own microservice. Each team would then interact with the APIs, and you can thereby scale. The problem with not doing it that way is that when you have lots of code, then you also need lots of communication. But if you abstract your code behind very concrete and immobile APIs, or at least APIs that are very exact, then you don't need to worry about people breaking what you're building, and that allows you to speed up. There's also another aspect of microservices, which is high availability. This is a more technical side of it. When you build microservices and you want them to be available, you often put, for example, your webs behind a load balancer, so that when a specific website goes down or a node goes down, that is just taken out of the load. There are lots of small tooling that you can use when you're building these things, and I consider going deeper into those, but it's just such a huge space that I think that would require at least 2 talks. But when it comes to high availability, you also have resources. Resources in this case are things that are connected to services. When you build your service, you want to focus on your logic, your code, and you don't want to focus on how the database is built. So high availability is a way of, well, you can structure your service so that when other services depend on you, they become highly available by your service being available. It comes from the top, where you got a load balancer, down to webs, down to databases. Then you also have redundancy, in the sense that if, for example, you look up for the latest wishes, the latest most wanted songs, if you're building a song service, then if that goes down, you can have redundancy and have a fallback. Because microservices are deployed separately, a failure in one microservice doesn't necessarily mean that all of the microservices fail. So another way of thinking about redundancy when it comes to microservices is that you make a request towards a multitude of those. You may have a web API and you make 5 requests to the same API and you select the one that responds the fastest. That's a good way of making sure that you always respond quick to your user. Otherwise, a latency issue in service far beyond the front, for example, in a database or in some index service far at the back, can reduce your latency times at the front to being very bad ones. But of course, there's a bit of trouble in paradise. For example, you have asynchronicity, so that when you send a message, when you send a request, you may never get a reply. And your method invocations, they're replaced with timeouts. So I'm just staring at this scary dude and losing my track. And that's exactly what your services can do as well. They just time out and you don't know what to do. Maybe it got stuck in a queue, maybe some service received something it couldn't handle and went down. And this is in comparison to when you write code normally. You often write code directly to objects or data structures. And when you make invocations towards those data structures, you know that they'll return because you're in the same process. But as at the same time that you add a network to the mix, you're going to have to replace your method invocations in your mind with timeouts and be able to handle those. You can also say that when you're building a monolith or a larger service which isn't distributed, your reasoning comes with types and your type system. And that's something F# is quite good at. But you can still build your, of course, microservices with types, but when you distribute them, you need to replace your types with monitoring. A bit more about the asynchronicity is this thing, the FLP impossibility proof. What it says is that under asynchronous computation in a distributed system, you can't be sure that you ever get a reply. And if you can't be sure that you ever get a reply, then you can't reach consensus. if you can't reach consensus, you can't agree on values, you can't have a consensus on them, and then there is no guarantee that your services continue to make forward progress. And then if you don't make forward progress, of course, your system halts and you don't serve requests anymore. So there goes your availability or your redundancy. And these are thoughts that you often lose in the heyday when you look at what microservices can bring. They can bring a lot of good stuff, but you also have to consider the negative aspects. So there is another trouble in paradise as well, which is that you have interleaved execution. Because when you execute your processes, unless you've built your whole system based on RPC, that is, unless you've built your whole system based on one service calling another synchronously and waiting for that service to reply, then you might be using messaging. If you're using messaging, you have interleaved execution. And that makes reasoning with it harder. When you think about a program executing, for example, you say assign 5 to x and then assign 7 to y, and then finally x plus y, you know that it'll execute in that order, or at least in an equivalent order. When you start distributing your services, you can't be as sure about when a service will work on a given message. And that makes it harder to reason about. So, how do you mitigate this? The first point I put here is DevOps, which is the combination, the culture of letting developers work together with operations to make sure that the code in production is your code in production. When you write a piece of code, you own it in production, and you don't throw it over the proverbial wall. You can also associate DevOps with tooling, and we'll dive a bit deeper into the different sorts of tooling. That's demo. The first one is logging, because when you start to reason about what's going on inside a process, and that process is suddenly temporally decoupled, or in another way of stating it, it's not running in the same thread as your main process, you need a way of inspecting what it's doing. One way of thinking about it is that if you can't tell from the logs what your service has done wrong, if something goes wrong, then you don't have enough logs. Logging is also the first thing you start adding as you move towards a microservice architecture, independent of language, because it's something that comes to mind very quickly. Another thing about logging is that you probably want to ship it off the node, off the computer which is running your service, because you don't want to be SSHing or RDPing into each of the operating systems you run your code on just to look at a file. So you need some sort of tooling to move things from where the logs are created to some sort of repository or display of those logs where you can filter and search them. The second one is metrics. I've also put the hardness here in terms of when you start out with microservices. Metrics is something that you start thinking of later when maybe you have a bit of load and you care about how users are interacting with your site, or you care about SLAs and latencies. Metrics are quite good to have in your system and have inside of your code, because if you do, then you're able to understand where things normally go slow and where things abnormally go slow. When you are faced with a production issue and you don't have any metrics, it can be hard to know if the system is operating at what it is supposed to operate at the level it's supposed to operate at. And that's why metrics are good. Finally, which is like a combination of logging and metrics, is tracing. I put advanced here because you need to basically tie in tracing into all of your libraries in order to make it happen. If you have been perusing Suave source code, you'll find that we've started to weave in a bit of tracing now with a trace header and so on, but we haven't quite completed that yet. What tracing does is that it creates a span, a holder, container per request. And then every sub-request of that request, when you call into your microservices in the backend, create their own small pieces of logging that you attach to the parent, that you attach to the overall request a person or a user is making to your website. A library which does this quite nicely is called Zipkin. And because it's the last level, I can honestly say that we haven't quite added tracing to our own systems just yet. We're going there, but if you're in the position of adding it, then I suggest you add it to Loggery so that you can have a single library for all of your metrics, tracing, and logging purposes. So that's sort of the introduction, and now I hope that you have a good idea about the foundations, why you might want microservices, why you might not want microservices, or at least what problems you might encounter when you start using them. So the demo now will be to set up Loggery using InfluxDB. And I have it all local, so I'm going to do a demo to first spawn InfluxDB and then Grafana, which is actually a Swedish invention, and then finally log to Grafana from F#, also showing you a bit about the new metrics infrastructure. So, demo time. So can you still see my slide?
We can see your screen, we can see your command line. We can see your command line just fine.
Okay, excellent. So I can use this. Maybe I can do that even.
Now we can see your command line and it's bigger.
Do you want it bigger?
This is good. No, I think a little bit bigger would be nice.
Okay.
And now we have it in a nice full screen mode. Oh, that's perfect. Yep, that's perfect.
All right.
Thank you very much.
Excellent. All right, so this is my personal dev folder. And in here I want to show the Loggery repository. I'm currently working on this feature, which is a log router that's supposed to ferry things from the nodes I talked about, ferry them off the nodes, ferry the logs and metrics off the nodes into some sort of proxy that then feeds it into InfluxDB. So as a part of this work, I've also made sure that we can run it using InfluxDB and Grafana. Now I'm going to kill the environment that I painfully set up. And this is how you do that. So Docker PS, that lists all of the containers you have running. And then you can remove them and delete the data in them as well by using rm-f, remove and force. By removing them all, we're starting out from scratch. So this repository is from github.com/loggery, which you'll also find a link for at the end of this presentation. I'll show you how to get all of this code. Of course, it's using rake, so you got a rake file there. So in order to build this yourself, if you want to try it out, you can run bundle exec rake, and you'll find how to download and start using rake also at the end of this presentation. But for now, we'll look at how to use Docker. I've created a file called docker start, and this is just for me to remember, because what it's doing is that it's running the Docker command here, which in turn is connected to my virtual machine called default, and that's running on VirtualBox, and it's running on my local OS X box. You can also see that it's assigned a local IP, 192.168.99.100. That local IP is possible for my computer to request things from. It's also possible for the Docker client, this thing, to talk to it, talk to the Docker daemon, which is running inside of a Linux, inside of VirtualBox. So what we're going to do is run these things, and then I'll explain what they do. So while that's starting up, let me walk you through this command. So docker run, that's how you spawn new containers. The D here means daemonize, and that's another word for run in the background. When you run something in the background, you get one of these hashes back, which is like an instance ID. The ports here, they're port mappings, and they're telling Docker what ports to expose from within the container, and then showing from the container to the Linux host that is running Docker itself, the Docker server. So I'm just mapping 8083 and 8086, which are the API ports for InfluxDB. When you run Docker scripts, you can, or Docker containers, those containers can be built using a number of scripts. And in this case, we have set an environment variable called pre-createDB, and we're creating a database called loggery. This thing only means that it's a new line, and these things are what my shell called fish, or Z shell, added. Finally, I want to expose these things from the host which is running the Docker server. So the host that is running the Docker server is this one, 192.168.99.100. It is not my local machine. So this is a NAT, you could call it, or just basically a port opening on that machine. I'm also naming the container so that I can find it when I do docker ps. Here's the name, and you can see that it's line broken here. The name is corresponding. Finally, this is the location that I'm pulling the container data from. When you run Docker containers, you're running a series of layers, which are your file system. Those layers build up the container and allow you to replace the latter parts. So for example, you could have a Ubuntu image, and then you can replace that with your, well, on top of it, you can put your own F# microservice, for example. In this case, we're running InfluxDB on top of lots of other things. So now we have something which is exposed, something which is running, and I think we're at the point where we can run Grafana as well. If you ever want to have a look at how Docker is doing, you can just do logs on it. So that's looking quite good, and you can see it's a WAL, which is a write-ahead log. And now we have both up and running. Okay, that means that we should be able to have a look at what's on this machine. This is the log, probably not showing quite that nicely in Skype. Sorry about that. Just gonna rest here for a while. So we can do a curl for 192.168. 99, 100, 3000. And if we add headers on top of that, you can see that it's redirecting us to the login page. And that means that we have something that should be working. So if I can show you that, I'm going to move away from this huge terminal and into a browser instead. So here we go. That's the redirect that you saw in the bash or in the fish shell. Now, when you set this up, it's admin as the user and password. But of course, when you deploy this, you sort it out. When you use Docker, you can use it both in production and in development. But when you use it in development, you quite often, you don't map any volumes, you don't have any persistent data. And there are a lot of extra things you need to add when you productionize Docker containers. Like, for example, when you productionize Docker containers, you need to add health checks. You need to add a good way of log shipping from the operating system, which is running your services. You also need to have some sort of networking, port mappings, and you need load balancing and so on. In fact, you need so many things that a project called Kubernetes has sprung up around it. So if you're interested in looking more about what it's like deploying on Docker, have a look at Kubernetes, depending on how you pronounce it, and familiarize yourself with what it's like. So back to Grafana then. Let's log in. And we're faced with a default, which is nothing configured. Now, we can also ensure that we have the database running called InfluxDB, and I believe that should be on 8083 localhost. So that's 192.8083, right. We only have two databases, the internal and the loggery one. So looking at the loggery one, we can now have a query template and show measurements that shows us the listing of counters or the listing of names that have values attached to them. Right now, we don't have any results because we don't have anything sending data to it. So we'll start by adding a new data source in Grafana, and we can call it InfluxDB, set it as the default, and then set the server as well. So this is the server. The 8083 port, that's for the web, and the API port is 8086. This proxy thing is so that you don't get CORS request errors. If that doesn't mean anything to you, that's no worry. Just use the default. Finally, you want the database and the user, which is defaulted to root in this demo and in the Docker container that we're using. So maybe, Thomas, I think we can hear you in the background. So maybe you can turn your microphone off a bit.
But the audience can't because we're filtering them out. So it's all good. But yeah, thank you.
All right, so let's save that and edit it back again. And then we test the connection. And we can see that it works. I realize I'm doing a lot of free advertising as well for 1Password here. Anyway, it's working. That means that it can talk to InfluxDB and authenticates properly. Not now. So now we go into dashboards, and you can see there aren't any default ones. You can template these out if you wish. But right now we don't have any data added either. So let's see if we can add a new dashboard here. We'll add a row, and then you got to find this green thing. We'll add a graph. Edit it. Was already edited. We'll add something as the name. And right now we don't have any measurements, so we're just going to leave it at this for the moment. And now the beloved F#. If this was a live audience, I'd hear a woo right now. But oh yeah, thank you. I did get a woo. Thank you very much. So it turns out I can't move things onto my screen unless I do this, which is less than good looking, but it means that I can actually show you code, which is nice. And this needs to be slightly bigger, maybe even more.
A little bit more would be nice. That's perfect. Yeah.
All right.
And
excellent.
we can see your lovely F# source code. Woohoo!
Yay! Okay. So here is the main thing. This is the entry point. It's spawning loggery, and this is using version 4 of the API. Version 4 of the API is actually a complete rewrite from scratch. It's a rewrite which gives you about 30 times the performance of the previous versions. The previous versions have been done using fsharpasync, and the new version is done using Hopak. It's probably me who wrote a bad implementation with fsharpasync, but Hopak seems to be quite fast anyway, despite my mistakes. So with the new API, we also are using the Hopak API. I'm not going to dwell deeper into that. The main part you need to consider here is that when you want to create a new logger instance, this is your metrics configuration and your logging configuration. You do something like this with Loggery Manager. Here you give the service name, which is quite good when you need to find metrics or log lines in Grafana or Kibana, which I haven't shown you, based on the type of service that you deployed. This thing, that's a function composition. So this, with Logger Manager, it takes a configuration function that acts on the Logger configuration object. So acting on that object means that it takes it and then returns it back as a new value. And that's why I can chain these things, because the last parameter of them is a loggerconf, and then it returns back a new value of loggerconf. So I can figure up a few targets. In this case, the console. The console is nice because it allows us to see what we're sending to InfluxDB. And then I'm also configuring the InfluxDB target, which I actually finished 2 hours before this presentation. So wee me. What it's doing is that it's creating a new URI. This is the endpoint that you're sending things into. And also you have the loggery database here. And this is visible when you use the API. So that's the DB that you see bolden here. You also give it a name. The name gives you the ability to filter things so that you don't log everything everywhere. For example, if you have a high frequency metric, you wouldn't want to log that into console because all the taking of kernel mutacies would kill performance, right? Instead, you would filter that out, and that's what you do with these rules. In this case, we're just creating a rule which accepts any input for the specified target, so we are going to log everything to console. We are also logging everything to InfluxDB. Now, one particularity with Logger is that it has both metrics and log lines, or messages, as we call them. And that makes for a nice API when you want to consider a log line or an event as a single metric of 1, which would allow you to find vertical bars in Grafana. That's also slightly outside of this presentation. It also has this internal logging thing, so you can debug. What we're showing here is a metric configuration, because the metrics is what Grafana is all about. I've implemented a random walk, a naive random walk probably, which looks like this. This is a function. It takes a point name here. That's the name of the metric. And then it returns some job metric that so the job here is just saying that it's asynchronously or concurrently possible to evaluate the value of this function call. what you should focus on is that it's a metric, and a metric is a part reducer and a part ticker, where the reducer is something that takes some state and then some thing and then returns the state again. The thing, of course, when it comes to loggery is that you got messages. You got things coming in from your call sites, from your own code. They may be events, or they may be gauges. Finally, you have the ticker. So it's a combo here. The ticker is responsible for taking some state, in this case a random instance, like literally a random instance, and some previous value, where the previous value is, well, what we previously logged. The previous value allows us to avoid just a completely stochastic plot. That's what the random walk is. So a bit of hacked code here, just to find a new value. It's just looking at the previous value, and then it's bounding it on -1 and 1. And then if it is outside, it inverts the value. Otherwise, it adds it. And the value itself can be either positive or negative. And this is just a coefficient to decrease its amplitude a bit, so that it doesn't oscillate too much. So that's the value. So the value is based on the previous value and some randomness. We're then creating a message of type metric from this value, which takes a point name and the value here. This is heavily inspired by Chiron, the JSON library. And finally, we're returning a new state and a list of messages that is then sent further into all of the targets we've configured. This is the initial state, and this is then how you create a new metric. So let's try this out. You can see here it's a console application. It's a simple program, and I've set it to start. So here we go. I call the metric Henrik because it's my random walk. It's my average distance of my fingers to the keyboard, and it's wildly oscillating. Now, what I have here is something which is logging to the console, and it's also logging to this, to Grafana and InfluxDB. Now what we need to do is to select a measurement, and you can see now that I clicked it that Henrik is displayed. This can be anything like disk size available or CPU usage. Or you can use the performance counters library, which also is built into loggery. As I click it, we directly get some vertical bar here, which has a mean of about 0. And we can use the time range to zoom out. So we want to show the last 5 minutes, and we also want to make sure it keeps refreshing. So here we go. Now we actually have live metrics being sent from F#. Imagine if this was your service and you could track your login, you can track your signups and so on. You can create amazing dashboards with this. So yeah, finally I can show you that if we run this, we also have Henrik here as a measurement. You can also zoom in if you wish and trace it further. All right, so that concludes my presentation, and now I'm open for questions if anyone has them.
All right. I'm gonna switch back so that we can see you. There you are. And we did get a couple of questions. So the first one that's here, it's what is the name of the library for tracing that you were using there?
So the library I was using for metrics is called Loggery.
Loggery.
Yes.
All right.
And it's here.
We'll switch back. There it is.
Exactly. I
Cool.
can also show you where you can find the presentation after this presentation.
Yeah, that's a good
so
pointer.
it's at huf/fsharp-micro.
Cool. So another question here. Will it work with F-sharp? Sorry. How it's going to work with F-sharp SUAF on the .NET Core?
Well, it is going to work. I believe Eric has Erico has sorry about names. You know names.
Yeah, I have.
He's done a lot of good work. So I can actually show that.
Yeah. So we'll have chat with David Stevens later on, and David's working on getting F-sharp to work on Core CLR, and then. There's I believe there's a pull request, right, for SUAF to make it work on .NET Core. So that's all coming.
It's already working, actually.
Oh, it's already done.
Yeah, it's been merged and it's been tested a bit.
Very good.
And you can also, and this is quite nice, with Docker there is something called Alpine Linux, which is like a tiny Linux distribution. And Mono runs on that distribution. So you can build your own microservices, and they're tiny to deploy. 5 megabytes for the Linux, 30 megabytes for Mono, and then 6-7 megabytes just for your service.
That's really impressive. So I guess we have time for one last question, and then we'll have to move on. That is, are there any plans for integrating with APM tools such as Datadog, New Relic, or Application Insights?
Yeah, so it's mostly built around what I use myself. And it's built around this thing that you can create a new target quite easily. So if you were to look inside of Loggery, you'll find this file called targets noop. And the targets noop is all you have to do. So if you switch to my screen again.
I have switched.
Okay,
you can see
then this is the main loop. So what you do is that you take some message that comes in here and you do something with it inside of this job. And that might be pushing to a new relic or doing something else. And this library handles the rest of the infrastructure for you. It also picks it off the thread and ensure it doesn't crash and so on. So it's quite easy to implement new targets.
Right, so that's pretty much a call to action. And Loggery is on GitHub, and if people wanted to work with any other targets, then the hint is send a pull request. It should be pretty easy to add, right?
Yeah, it should be. And I'm here to help. There's also a Gitter you can use, which allows you to discuss it. So
all right, so there's a place to ask if you need help.
Yes, exactly.
Very good. I think we have to move on to the next talk. So Henrik, thanks again for joining us, and thanks for staying late tonight. It was really cool talk, and I'm personally really happy to see so many cross-platform themes as part of the conference. So,
right, so
thank you very
much. Summary then, if you want to stay in touch, have a look at twitter.com/HenrikFelt. Or maybe if you want to learn some F-sharp, you can go to fsharp.tv, where we're holding courses in both F-sharp programming and how to do web development. There are also links to both Loggery and my GitHub there. So stay in touch.
Perfect. And you should definitely check out F-sharp TV. We have actually a link at fsharpConf website as well, because they've been kind enough to help us promote the event. So Henrik, thank you again, and talk to you later. Bye.